Welcome to SAEC YouTube channel for GATE. This is Ms.K.S.MARGARET, Assistant Professor from EEE Department. EEE Department accredited to NBA at SA Engineering College, Chennai 77, accredited to NAC. So today I am going to take class on control system. And the syllabus is modeling and mathematical modeling and representation of the system, the fundamental of the control system. So let us see what is mathematical modeling and what do you mean by representation of systems. So any system, any physical system can be represented in terms of mathematical equation. So that is the basics of mathematical modeling. Any system, most of the time all the physical models can be easily represented in terms of your electrical equation, in electrical circuits with respect of your resistance, capacitance and inductance. Similarly, the mechanical system, it can be physical, any physical system can be represented in mechanical system also in terms of your force, mass, dashpot, spring, all those things. The mechanical and the electrical system have their own analogous circuits also. So based on that, their fundamental principle, we can form the mathematical equation and from there we can create the models. So mathematical model is generally deriving the model from the basic or fundamental governing equations. So how can we represent these systems? So generally any system can be represented using differential equation. Whatever be the complexity of the system, each and every endpoint, every system, every inner complexity can be represented easily by a mathematical equation. So first thing of representing a system is using a differential equation. So using this, the dynamic behavior of a system can also be easily represented. Second one is your transfer function. So transfer function, differential equation is mostly, it is used to define the system or the governing equation in time domain. When we go for transfer function, it is used to define the system in S domain. So the definition for transfer function is, it is a ratio of Laplace transform of the output to the Laplace transform of the input at zero initial condition. So any system in S domain, if you know the output and the input, you have to take the Laplace transform and the ratio of that will give you the transfer function of the system. And state space model, you have state equation, output equation. You can create the state equation and output equation from the basics of your differential equation itself, and you can create more number of states, and using the state equation, output equation, you can form a matrix, and with that you can find out the different measurable systems, observable systems of the given system. So that is one method of representing the system in state space. And block diagrams and signal flow graph, again any complex system, whatever be the complexity of the system, you can represent the system in blocks. You have so many blocks, all these blocks can be easily reduced using a block reduction technique, and finally you will get a single block which has one input and one output. You will have only single block. So that will give you the transfer function of the system. And second one is your signal flow graph. These block diagrams can be directly converted into signal flow graph, or if you can represent the system in a signal flow graph using the nodes. If you know the gains, if you know the loops of the system, you can again finding the gains of the loops, forward paths, everything. We have a formula called Mason-Gains formula. So substituting in Mason-Gains formula, we can find the transfer function of the system. So I hope you would have understood what is a modeling approach. We need to, any physical systems can be represented using a electrical or mechanical or analogous, any analogous circuit which obeys the physical laws, and from that we can differentiate or define the governing equations, and it can be represented in terms of differential equations, transfer functions, state space model, block diagram and signal flow graph. So let us see what is this mechanical to electrical analogous signal. So if you take mechanical system, we will consider force as the input. And in mechanical system, we'll be taking into two types. One is translational, the other one is rotational. So in case of translational system, the input is force, which is again a linear force. So when the input is given as force and the components or the system will have a mass, weight, mass which is subject to the force. Because of the force, you'll have a displacement, and that displacement is indicated by x. And when there is a change in the displacement, it is called as your velocity, and which is indicated by dx by dt. And when there is a change in the velocity, it is indicated as your acceleration, which is indicated by d square x by dt square. And the three main components in your mechanical system are mass, dashpot, and spring. So mass is indicated by m, which is related with your acceleration. B is your dashpot related with your velocity, and K is a spring, which is directly have the relationship with your displacement. So all these components can be shown with an electrical analogous circuit. So in translation system, where your input of mechanical system is force, in electrical system we have two types of system. One is force voltage, force current. In the sense, you can give voltage as an input to the circuit, or you can give current as a input. So in case of force equivalent in your translation, when your input is force, it can be the analogous in electrical can be voltage, or it can be a current. So when you give voltage as the input, the output will be a current. When you give current as the input to the system, your output will be voltage. Now we will see how mass, dashpot, and spring of mechanical system can be shown equivalently or analogous circuit in electrical system. So first one is your mass. So the equation for mass is F is equal to m d square x by dt square. In case of force voltage system, where your input is voltage for electrical system, you can represent your mass by inductance L, and therefore the relationship V is equal to L di by dt. I is the current flowing through the circuit. And similarly, when the B is your dashpot in your mechanical system, and this dashpot and is equivalent component in electrical system when your input is voltage is resistance. So the relationship between voltage and current with respect to resistance is V is equal to I into R, or R into I. And similarly, the equivalent of your spring in case of mechanical with respect to electrical when the input is voltage, that is capacitance, which is given by V is equal to 1 by C integrated I dt. I is the current flowing through the circuit, which will be your output. Now in case of your rotational system, the same analogous will be applied to in rotational system also. Only thing is, instead of force, you will give a rotational force, which is called as your torque. So when a rotational force, that is torque, is applied to a mass, you will have a change in your angular displacement takes place. Okay, so that angular displacement, change in angular displacement is indicated by your angular velocity. Change in angular velocity is again can be represented as your angular acceleration. So here, instead of mass, we will take moment of inertia of the mass. So that is indicated by J. And as usual, you will have your dashpot and the spring, which we have seen in your translation system. So instead of displacement x, we are concentrating on angular displacement because the force is angular. So torque is applied to the system. So here we can represent your torque when it is applied to a mass. You will have a moment of inertia J, and the relationship is given by T is equal to J d square theta by dt square. And when it is applied with respect to dashpot, it is indicated by T is equal to B d theta by dt. And with respect to spring, it is given by T is equal to K into theta. So as earlier I said, force equivalent for both the torque and voltage equation for both force and torque is the same. Okay, and when you go for current, in the sense, when your input is current, your current will be taken as input. You have to write the relationship in terms of your voltage. Voltage becomes your output. So for mass, the equation, equivalent analogous equation for in electrical is, when your input is current, is I is equal to C dV by dt. And similarly, it is the same for your moment of inertia also, which is equal to I is equal to C dV by dt. And for dashboard, it is V by R. Here also it is V by by R. For current 1 by L integrated V dt, it is 1 by L integrated V dt. Same thing when the current is given as input. Okay. Now let us see what are the physical laws we are using. So in mechanical, the physical law it obeys is your Newton's second law. And in electrical, when your input is going to be voltage, it is going to obey your Kirchhoff's voltage law KVL, and when the input is going to be current, it is going to behave your Kirchhoff's current law KCL. So generally we can write this equation as when you have all in series, your mass, dashpot and spring, you can write the force equation as F is equal to m d square x by dt square plus dx b dx by dt plus kx. If it is a rotational system, you can write it as torque is equal to m d square theta by dt square plus b d theta by dt plus k theta. And similarly in electrical, the equation when the supply voltage is given to the circuit when R L C are in series is IR plus L di by dt plus 1 by C integrated I dt, and in case of current it is V by R plus C dV by dt plus 1 by L integrated V dt. So these are the governing differential equations for both mechanical and electrical system. So we can say that the systems can be again divided into linear time invariant system and non-linear system. So linear time invariant systems means it will have constant coefficients and it will not vary with respect to your time. Non-linear system is it will be having more complex system. All the system will be varying with respect to your time period, and because of that you need to go for linearization methods, and you have to go for some single signal conditioning system so that you can amplify the system, or you have to reduce the noise, you have to filter the noise systems, you have to attenuate some signals, or whatever process you have to do it. All the non-linear system, first you need make it linearization, and then only you can go for applying the other criteria. So as I said, we have seen this electrical analogy for mechanical system. What are the electrical analogy? When the input is voltage and when the input is current, both for translation and rotational system. So let us go for the gate questions. So in gate EC Electronics Department 2018, this question was asked related to transfer function. So mostly this mathematical modeling questions will be very basic. They will be asking about the analogous of mechanical to electrical system, and very simple questions when you ask, because there will be the derivation of transfer function using block diagram signal flow becomes a major problem in your gate question. So all these use in mathematical model, the questions will be a little simple, sometimes only it will be a little difficult. So very first question I have taken is your transfer function. So as I was discussing the governing equations of your electrical and mechanical system, we know how to write the differential equation. So here they have given you the direct question, which is d square y by dt square plus 3 dy by dt plus 2y is equal to u of t. So where y indicates your displacement. So where there we have written in terms of x, here it is y. So d square y by dt square indicates your acceleration, dy by dt will be velocity, and 2y, y is your displacement, is equal to your input u of t. So for transfer function, the main condition, the definition is it is a ratio of Laplace transform of output to Laplace transform of input at zero initial conditions. So now in this case, we are going to take the Laplace transform. When you take the Laplace transform of the system, d square y by dt square will become s square into y of s. 3 dy by dt will become 3 into s into y of s, plus 2y will become 2 into s, which is equal to Laplace transform of u of t is u of s. So we have taken y of s commonly, so we will get s square plus 3s plus 2. And transfer function is your nothing but the ratio of output by input. So output is your displacement y of s, u of s is the input what we are giving. So your transfer function g of s is nothing but y of s by u of s, which is equal to 1 by s plus 1 into s plus 2. Nothing but the same thing, s squared plus 3s plus 2 only can be rewritten as s plus 1 into s plus 2. So in case of your gate questions, in whichever form the equation is given, you have to select that. If directly they are given s squared plus 3s plus 2, you can select this answer. Otherwise, if it is given in the other way, you have to check which equation exactly matches the answer and you can give the answer. Next one is your gate question from 2017, triply gate question from 2017 for mechanical system. So they have taken a mass spring damper system where m is equal to values of mass is given as 1 and c is nothing but your dashpot, that is a friction coefficient, which is given as 2, and k is your spring value, which is given as 1. So we need to find the transfer function. So as we have seen in the previous slide, the governing equation, when you have all your mass, dashpot and spring for a mechanical translation, I mean they have not specified whether it is translation or rotational, but whatever it is, the equation is nothing but F is equal to m d square x by dt square plus b dx by dt plus kx. So in this case, you can see when you take the transfer function, I mean if you take the Laplace transform, for transfer function we need Laplace transform. So when you take the Laplace transform of the system, f will become f of s, which is equal to m into d square x by dt square can be written as s square into x of s plus b s into x of s plus k into x of s. X being the displacement and that is your output. Force is the input what you are going to give to the system. And the values of m, b, k are given, which are nothing but m is equal to 1, b is equal to, b is nothing but your friction, which is equal to c in the question, which is equal to 2, k is equal to your spring value, which is equal to 1. So now when you substitute all these values, you will get f of x is equal to x of s into s square plus 2s plus 1. So we all know the ratio of these two is nothing but 1 by s square plus 2s plus 1. So as said in the earlier, whichever answer is given in whichever form which suits your answer, you have to select that. So if it is directly given 1 by s square plus 2s plus 1, you can select this, or if it is 1 by s plus 1 the whole square, if you expand this, the answer will be the same, s square plus 2s plus 1. Next question is from gate question, EC question paper 2016. So what in the question they have said is a RC circuit is given, they are in series and the output is taken across the capacitor. So R and C are in series. For RC circuit generally they have given and the output is across the capacitor. So for Laplace transformer we have to take the output voltage across the capacitor as the output 1 and the input is your source voltage whatever you are giving. Okay, therefore the ratio of Laplace transform will be, a transfer function is equal to Laplace transform of voltage at the output across the capacitor divided by your input is your source voltage. So simply we can draw this circuit like this. I have given a supply voltage of V of t and we have a resistance and a capacitor in series and the output is taken across your capacitors, which is indicated by V C of t. So current I of t flows through when it is a closed loop circuit. So overall the total supply voltage is nothing but the voltage across your resistance plus the voltage across your capacitance. So you can write your total voltage is equal to VR of t, which is nothing but your voltage across your resistor, plus VC of t, which is nothing but your voltage across your capacitance. So again, what is VR of t? We need to find the transfer function in terms of VC because that is your taken as your output voltage. So first we need to see that we write the equation in terms of your VC of t. So voltage formula is current into resistance, we all know that. So here VR of t, the current flowing through your resistance I of t. So VR of t is equal to R into I of t plus Vc of t. I of t is nothing but, since both these are connected in series, R and C are in series, the current flowing through your resistance will be the same current flowing through your capacitance. So when you write that in terms of your capacitance, you can write it as R is equal to, current formula for capacitance is C into dVc of t by dt. So we have got the total voltage equation in terms of your capacitance voltage. So total voltage V of t is equal to R into C dVc of t by dt plus Vc of t. So now we are going to take the Laplace transform. When you take the Laplace transform, V of t becomes V of s, which is equal to R into C into dVc of t by dt is nothing but s into Vc of s plus Vc of s. So now Vc of s is taken as commonly outside, so that will give you RCS plus 1 inside. So now what happens? Again, as per Laplace transform, ratio of output to the input, Laplace transform output to input as 0 initial condition will give you the transfer function. So when you take the ratio, your Vc of s by V of s is equal to 1 by RCS plus 1. We'll get 1 by RC plus 1, that is your transfer function. But since in gate questions where the values of R or any component values are not given, we will be taking the values as 1. R value is equal to 1 and C value is also equivalent to 1. So therefore your G of s value will be equal to 1 by s plus 1. So these are the different gate examples they have asked in your gate questions based on your mathematical model. So you have to find the transfer function. To find the transfer, first we need to know the differential equation. If the block diagram and signal flow is not given, you should know what is the differential equation. If a circuit is given, first write the differential equation, and from that you have to take down all the values. You have to find the Laplace transform and you have to know what is the output and what is the input, and using that you will be finding the transfer function of the system. So this is about the mathematical model and representation of system. Thank you very much. We will continue in the next video. Thank you.